want us to do this definite integral. We're going to use these integral formulas. Which one are we going to use? We're going to use the square root one because we have a square root in the bottom. So we're going to use this one. Whenever you use a formula in math and science, you've got to do plastic surgery. You got to remove the wrinkles, give this a new look so that it looks like that one. Then you can use the formula. Okay, so what do I mean looks like this one? Well, this one says you got to have something squared minus something squared. So I think, oh, okay. So what is how do you write this? This is 8 squared, 8 times 8 is 64, minus u squared. It's got to be something squared minus u squared. So u right there is just x. So yeah, you don't need to really make that change. If u is just x, you don't need to do. I mean, if you wanted to write u as x, then du dx is going to be 1, right? And then multiply by the dx on both sides. Derivative of x is 1, cancels. Du is just going to be dx. So there's no point. I mean, if you want to do that, you just say, okay, that's du now. That's fine if you want to do that. So then it's the integral, and it's on the bottom, it's 8 squared minus u squared du. So now we've made it look like this, haven't we? Right? Where the a is 8. So what is it equal to? Well, the formula says it's equal to the, right here, arc sine of u over a. So it's the arc sine of u over what's a? 8, right? U over 8. And then we can go back to x. X and u are the same thing, so I can just make this an x on the top. All right, but we're not done there because this one is a definite integral. We're going to go from -4 to +4. So I got to evaluate that thing now from -4 to +4. So let's plug in. We're going to have arc sine of x. Whoa, sorry. Getting a little confused. We're going to plug right in there. So it's going to be 4 over 8 minus arc sine of -4 over 8, right? Oops. So you plug in the top bound minus plug in the bottom bound. Okay, so arc sine of 4 over 8. Let's go find out let's just go type this whole thing into our calculator. Arc sine of Desmos. Arc sine of 4 over 8. Um, I'm going to go, okay, that's inverse sine of 4 over 8 minus the arc sine of, was it -4 over 8? I think. Minus arc sine of -4 over 8. There we go. And we got to make sure we're in radian mode. We are. There it is, 1.04719, 1.04719, 1.04719. Is that what they got? Oh, they said pi over 3. Is that the same thing? It absolutely is. Let me prove it to you. So pi over 3. See how that's exactly the same number? So you can say pi over 3, or you could say it this way. If you're wondering, well, how do they know it's pi over 3? Well, it's because this is really the arc sine of a half. I don't know if you remember your trig. Where is the sine? What is the angle where the sine is a half? It's pi over 6. And this one is the arc sine of negative half. What is the angle where the arc sine is negative? It's negative pi over 6. So that's why, if you're interested, the double negative here becomes positive, and so you get pi over 6 plus pi over 6, which is 1 pi over 6 and 1 pi over 6 is 2 pi over 6, which indeed is pi over 3. You don't have to remember all that stuff from trig. It's all right. You can just give this answer. It's the same thing as pi over 3. And so let's recap real quick what we did. Whenever you use a math science formula, you got to do plastic surgery. You got to make it look like the formula. Then you can use the formula. So how did I do that? Well, it's got to be something squared minus something squared inside the square root in the bottom. So I made this 64 into 8 squared, and this is u squared. And so then u, really you could skip all this because whenever u is x, nothing's really changing. So, right, dx just becomes du and just like this. And so now it looks like the formula, so I can use it. Arc sine of u over a, and that's x over 8 because the a, first number squared, is 8. And then plug in the top bound, plug in the bottom bound with a minus sign in between, hit the buttons on your calculator. There we go.